All right, today we're looking at our first day of Riemann sums. Riemann sums are a way to approximate area under the curve, and we have four Riemann sums we're going to be using in this class. The first ones are by rectangles. We'll have a left and right-handed Riemann sum. So if we wanted to estimate the area under this curve, that means we want to figure out an approximation for what this area would be. Now, we saw how important the area could be when we were doing the interpreting derivatives lesson last unit. And so this area could be very important to us in finding something out about the graph. Now, when we say a left-hand Riemann sum, as I said earlier, that means we're going to draw rectangles under the curve in which the left side of the rectangle touches the curve. So this is the one we're looking at first. Left side of the rectangle touches the curve. And we're going to find the area of those because we can find the area of these rectangles. All right, so for example, this rectangle right here has a width of 1 and a height of whatever this function's value is. So that would be f of 0. And this area, or this rectangle's area, is another length of 1 and a height of this one. So that's the f of 1. Now, this would not be a very accurate approximation, but this would be 1 times f of 0 is 1, plus 1 times f of 1, which is 2. So this would be about 3. So the area is about 3. Now, we can see here, we have some space here that's left out. So that's a pretty low approximation. So there are a couple ways we could make this more accurate. The first one might be to use something different. I know a lot of y'all are screaming at me, well, use a trapezoid. It's more exact. We'll get to that tomorrow. The other way is to use more rectangles. So we could use smaller subsets. So instead of from 0 to 1, we could do 1/2 and then 3/2. So now, when we draw our rectangles, we'll see we have a lot less space left over there that's not being covered. And so we can use smaller subsets. And that could make our rectangle. Now, so let's set up this one. This would be, all of them have a width of 1/2, so 1/2 times. And then since the left side, it's the height on the left side here, so times f of 0 plus 1/2 times f of 1/2 plus 1/2 times f of 1 plus 1/2 times f of 3/2. So that's rectangle 1, rectangle 2, rectangle 3, rectangle 4. That's all our rectangles. And we would plug them in and solve. So this is 1/2 times 0, which is, or times 1, which is 1/2. 1/2 times 1/4 plus 1, so 5/4, so 5/8. 1/2 times f of 1, so that's 2, so 1. And then 1/2 times f of 3/2, so 9/4 plus 1, so 5. 14/4 simplifies down to 7/2 times 2, so 7/4. And so we would simplify this together, and this would give us our left-handed Riemann sum. Okay, and so we could make some ways to make it simpler. We could say it's 1/2 times, and then f of 0 plus f of 1/2, plus f of 1 plus f of 3/2. Notice how this whole thing is set up with the y values of the left side of each rectangle, or what we call subintervals. So we have subinterval from 0 to 1/2, subinterval from 1/2 to 1, 1 to 3/2, and then 3/2 to 2. So we're using the left side of each of those subintervals. Now the other option is a right-handed Riemann sum. Right hand does the same thing, except now we use the right side as the side that touches. Okay? Now, this would still be an approximation, but still inaccurate because we have all this space over the curve that's also being covered. Once again, it can get more accurate by using smaller subintervals. Now this time, when we set it up, it's going to be very similar. They all have a base of 1/2. But this time we're using the right endpoint of each of these subintervals. So I'll just start from the right side, f of 2, f of 3/2, f of 1, and f of 1/2. Notice this time we won't go all the way to f of 0 because f of 0 is not one that actually touches on the line. Our right endpoint is the one that always intersects with the graph. Okay? And we can plug that in and solve as well. All right, so let's actually let y'all do one, and we'll look at one together. Okay, we'll come back to that one in a second. Let's go back to here. All right, so well, we did the left hand. Let's do the right hand for this one. So we want to estimate the area under the curve with a right-hand Riemann sum with 4 subintervals. So 4 subintervals means we need to take the whole area from 0 to 2 and break it into 4 equal subsections. So we have 0 to 2, so 2 minus 0 over 4. That means we want subintervals of 1/2. So we'll break it into 1/2, 1, 3/2, and 2. So our subinterval is 1/2. And then we're going to use the right side of each of those subintervals. So the right side is f of 2 plus f of 3/2 plus f of 1 plus f of 1/2. Plug those in. F of 2 is going to be, well, we can see it there, 5. F of 3/2 is going to be 9 over 4 plus 1, so 13 over 4. F of 1 is going to be 2. And f of 1/2 is going to be 5 over 4. Simplify it all together, we get 18 over 4 plus 7, and then all times 1/2. 18 over 4 simplifies down to 9 over 2. Well, we'll erase. Nine over 2 plus 7. So that's 9 over 2 plus 14 over 2. So 23 over 2 times 1/2, so 23 over 4. Okay? And that's the whole idea. What is the Riemann sum? All right, one more we're going to look at is one with a table. Now this one, we're just going to break it up into our subintervals. So we want to use as many subintervals as possible. We'll do the left hand, and you can try the right hand on your own. So let's look at our subintervals. We have 0 to 2, 2 to 5, 5 to 7, and then 7 to 10. Now, unlike the last ones where we had the same distance between the subinterval, if we're using left hand, that means this rectangle uses this y value. So we have 2 times, and then the width of this rectangle. Well, the width of this rectangle is 2. Plus, this rectangle now is using this one times the width, which is 3. Oops. So 3 times 3. Notice we're creating a rectangle for each because they don't have a common width we can pull out. So the next one is 5 times the width there, so 5 times 2. The next one is 7 times this last width, so 7 times 3. And then that covers all of our rectangles. And we'll multiply and simplify. So 4 plus 9 plus 10 plus 21. So 31, 44. 44 would be our left-hand Riemann sum. All right, you have some practice you can do on your own. Let me know if you have any questions. You all have a great day.